Welcome, ladies and gentlemen, to Commodity-TV in the new edition of our online interview series. Yeah, we want to talk now for the first time to LI Metals, and Maciej Jastrzebski is with us, the CEO. Welcome, and good morning to Canada. How are you, Maciej?
I'm doing very well. Thanks a lot, Johan.
Yeah, perfect. Good to see you. And really interesting as we have you the first time on our TV show here. And I mean, lithium is definitely, something which is in the news, which is I wouldn't say in a hype because we really need it for e-mobility. And the markets are really growing. So really interesting what LE Metals is doing, because you are not like a miner. You are, I would call it more like a lithium technology company. So can you shortly describe the company? Where are you based and what is the purpose?
Sure. So LI Metals really focused on developing and commercializing technologies for next generation batteries. And the main focus of the company is really on high energy anode materials. So we work in two main areas, the production of lithium metal, so metallic lithium, and transformation of that lithium into very high performance anodes. So actually a battery component. So we really kind of occupy the midstream between the chemical producers and the battery producers. So the company is about 3.5 years old now. We started in sort of late 2018. We're based in Toronto, Canada, and we have an operation just north of Toronto and pilot production facility in Rochester, New York.
Okay, super. When you say next generation batteries, will it not work for, let's call it, for the first generation? What is the difference?
So I think it's important to kind of take a step back. So lithium ion batteries have been, the workhorse of the electrification revolution. We've had about 30 years of good, I would say, good progress from those batteries. We've had lots of incremental improvements. But eventually you hit a sort of physical, theoretical limit as to what those batteries can deliver. And we're starting to approach that very, very closely now. And so at the same time, we've had lots of work on what I would call the successor technologies to lithium-ion batteries. We've seen solid-state batteries start to enter early-stage commercialization. We're seeing the same with hybrid batteries, so advanced liquid electrolyte batteries. We're seeing it now also with lithium sulfur batteries. We're seeing it with all of those different permutations, also with silicon anodes. So there's really a broad range of next generation battery technologies. Most of them, what they have in common is, rather than squeezing out extra performance from the cathode material like we've seen with the lithium ion battery, now they're focused on the anode. That's really where the big gains are going to be made over the next decade. And so our company is focused on that. We're really a forward-looking company. We're trying to build out the technologies for that supply chain and on the anode production side. So we're constantly growing that IP portfolio. I think we have something like 22 patent applications in progress right now. We're a young company, so we're still relatively early in the development of that IP portfolio. And there's just tons. It's like a white space opportunity in all of these areas. So we're very excited. We're expecting to have our first 1 or 2 patents granted in relatively short order. But of course, it's not only up to us; it's also up to the patent offices and so forth.
Of course, super. Okay, but because I think this is very important to protect your company and the shareholders.
Absolutely.
Also, right?
Absolutely.
Okay, super.
And actually, Johan, I'll just mention that because it's an important point. So one of our most recent additions to the team is Dr. John Goodman, who's our chief scientist now. He's taking over. He's taking over the product development process, and he's also now managing the IP portfolio. And so he's actually very qualified to do that because he is not only an accomplished researcher, but also many years as a patent attorney. So we really were looking for that combination, and we found it in John, and I think he's going to be a great contribution to the team, really in helping to protect all of this great technology we're developing.
Okay, super, perfect. Then question, when I look through your presentation, it looks to me like that with your technology, you can even do a higher energy density. And I think this is key for the future, right? Because today we have a reach of 300, 400, maybe 500 kilometers with batteries. But I think to really get it into the market, you need at least plus 600 kilometers, because we live here in Switzerland. And as you in Canada, I mean, we have minus 15, minus 20, and the battery range goes like, blah. Right?
Yes,
I mean,
indeed.
I'm driving a hybrid, and I lose in the winter 30% of my range.
Yeah, no,
So
it's a huge thing, and I mean, this is really where the next generation batteries shine. All of them make very significant improvements to the energy storage capacity of the batteries. You know, for a given mass or a given volume, you know, you're talking about gains sort of in the order of 25 to 100%. So, you know, in some cases, doubling the energy storage capacity of the battery. So it's going to be a sea change. Not only that, you know, it's going to enable EVs. It's really going to eliminate range anxiety as a concept. But I think just looking ahead, you know, the applications like electric air mobility, all of them rely on very high energy density batteries, and really those are the kinds of niches that start to open up as well when these technologies are commercialized. So it's a very exciting space. To unpack that, you really kind of have to understand the where next generation batteries are today, what types of anodes they're using. So in most cases, especially in particular the lithium metal based batteries, they rely on lithium foils. So lithium foils are produced using an extrusion process and a rolling process. So you basically take a big chunk of lithium metal, you squeeze it out through a narrow slot, and then you roll that down into something that looks a little bit like the aluminum foil you might find in your kitchen drawer.
mm-hmm.
The problem with that is that process is actually very difficult to scale. It gets sort of prohibitively expensive as you approach the thicknesses you would want for your battery, and almost impossible to roll anything approaching the width that you need for an automotive battery. And so the compromise that people make is they produce foils that are quite narrow and quite thick. So you end up having more material in the battery, which means more volume, and that also compromises safety because you're putting more reactive material into the battery. So what our technologies allow us to do is to really thrift on that anode material. It allows us to produce very wide format anode materials, and really to customize that to any of those particular technologies, whatever they may need. Some of them require a little bit more lithium inventory, others can do with very little. And so the idea here is you're really only putting in the material that you need for the battery to function. And that's what allows you to squeeze those energy density and specific energy metrics.
Mm-hmm. Okay, super. Now we have spoken a lot about technology, about your advantages. What is about cost? Are they even cheaper than today's material?
So the big advantage, and it's the different battery types have different advantages.
Mm-hmm.
A lot of solid state batteries, for instance, can eliminate a number of the manufacturing steps.
Mm-hmm.
Lithium sulfur batteries use sulfur as the cathode material, which is very inexpensive compared to the mixed metal oxides. So one of the big things, but all of that aside, one of the big drivers, the cost drivers today for next generation batteries, is actually the cost of the anode material.
Mm-hmm.
Foil production is quite expensive, uses a lot of metallic lithium. Metallic lithium is at $450 a kilo right now, so it's a tremendous cost driver. And so the way you get around that is you produce large format materials at a high rate with a cost-effective process while minimizing the material use. So the process we've adapted, that we're adapting to produce our anode materials, that process is the same process by which you produce packaging rates at a high rate and a very low cost, and that's what our technology is based on. So really, when I talked about low material use, high throughput, low cost production, and large format, this ticks the boxes for all of them.
Mm-hmm. Okay, super. So let's have a look on the environmental side.
Mhm.
Um, what is the difference in your technology? I saw you are not using any chlorine gas. What is, let's say, your CO2 footprint, for example, stuff like this?
Yeah, so that's an important point. I mean, we've talked a lot about the anode materials because, of course, that's the bit that goes into the battery. But if you can produce the anode, you still somehow need a source of the metallic lithium that actually goes into the material. So we have developed a production process for metallic lithium that uses lithium carbonate as the feedstock.
So you can produce by yourself metallic lithium, which is today
Yes,
$450 the kilogram.
yes, that's one of the pillars of the company because
Okay.
we see we see what's happening in the battery market today. There's a mad scramble for raw materials and intermediate materials, and we expect that as we get into the second half of the decade and as next generation batteries start to gain more and more and more momentum, exactly the same thing will happen with lithium metal. So in part it's a hedge, but in part it's also potentially a profitable business on its own.
Hmm.
But I'll go back to your original question, which was what about the environmental impact?
Yeah.
So the traditional way of producing metallic lithium is you take lithium chloride salt and you electrolyze it, you split it into two, and you get for every 1 kilo of lithium metal, you get 5 kilos of chlorine gas. And chlorine gas is a highly corrosive, highly toxic
Hmm.
material. It has to be captured. It has to be cleaned. It has to be somehow remediated or sold as a byproduct. And that's a big problem when you're thinking about massively scaling up this capacity, both from a permitting point of view, but also from a supply chain point of view. Not a lot of lithium chloride, high purity lithium chloride gets made today. Again, just strategically thinking about scaling the company and scaling this industry, um, what we saw as a huge advantage was being able to bolt on the lithium, the existing sort of lithium ion battery supply chain onto our supply chain. And so that's what we do. We take lithium carbonate, of which there's lots of production capacity in the world today, and we use that as our feedstock. So by doing that, we get two benefits, actually three. One is the supply chain security is much improved. Two is the permitting difficulty and the cost of production actually goes down because you can eliminate all of this chlorine gas handling equipment. And three, the environmental impact is also reduced because you're not producing this toxic byproduct that you need to deal with somewhere.
Hmm.
So that's, I would say, the main environmental impact. There's potentially also sort of general carbon footprint benefits. To split lithium carbonate takes a bit less energy than to split lithium chloride. In fact, it's quite a bit less energy. But that's yet to be proven at the larger scale
Hmm.
when we start to demonstrate our technology.
Okay, demonstrate the technology. That's my next point. Also, you have a pilot plant already, so you
Yes.
are really working already on your let's say future production. Um, what is the scale by today? When do you think you can start your commercial plant?
Right. No, that's an excellent question. So at the moment, we have, as I said, we have two facilities. We have a facility in Rochester, New York, which is already producing sample anode materials. This is at what I would call an intermediate demonstration or pilot scale. It's it's not commercial scale production, but it
Hmm.
allows us to produce large quantities of sample product that we're now supplying to our various customers.
Hmm.
Um, so that capacity is established, and it's really there to help our partners qualify our products in their batteries. And the plan there is that in 2023, we will be building a commercial scale demonstration plant. So this would
Hmm.
really be like a single instance of a full scale production line. It
Hmm.
would be on the order, hundreds of megawatt hours of equivalent production capacity. And really that will, beyond that point to scale is merely to copy that line many times over.
Hmm.
And so the idea is to get to the gigawatt scale around 2025. That's
Hmm.
where we see the demand really start to pick up. But already there's substantial sampling demand. We are already getting actually increasing scale of orders even for our pilot plant. So when we talk about that commercial scale demonstration plant, it's not just a demonstration plant. It actually becomes a commercial operation, supplying the product qualification needs and early commercialization of these batteries.
Okay.
So that's on the anode side. On the metal production side, we have at our Markham facility, we're just actually in the very early stages of piloting our full-scale, basically industrial-scale demonstration unit. Again, similar concept. It's a single unit of approximately industrial scale that, once demonstrated, we can roll out in multiple unit production lines. So at the moment, at the moment, the demonstration capacity there, we're aiming to have that fully demonstrated by the end of the year. And the timing of the first commercial scale lithium metal operation sort of depends on whether we want to feed our own anode operations or external customers. And we've had interest. We obviously have our own plans, but we're starting to get interest on the metal side as well. So that plan is yet to be determined.
Okay, super. So what is the feedback so far from the products you have delivered? Do they like it, or have you been rejected even?
No, it's excellent feedback. I mean, the order book speaks for itself. We're getting thousands of meters of orders. To put that into perspective, last year we were able to produce about 1,000 meters of material, all of it taken up by customers. This year already we've produced something like 2,500 or 3,000 meters, and we've got orders for thousands more meters of material. So the feedback is largely very, very positive. And I would say we're just getting started, because this is really on the entry level product. This is you might say it's like foil, but produced with a much cheaper production process. But we have this very rich pipeline of additional products, ones that allow us to really affect the performance, to do with the product much more than can be done with foil. So it's very, very exciting. The development team has been working very hard to bring the technology, to mature the technology, but also to make sure that we have, let's say, technological scope to make sure we stay in a leading technological position in the industry.
Okay, super. So what would a commercial plant then cost? Do you have the money already?
So for a commercial plant, no, we're not funded for the commercial plant. We believe we're very close to being funded for the commercial scale demonstration plant. We're just in the process of doing the engineering studies for that, but from sort of initial estimates, it looks to be that way. The commercial plant is obviously, it's yet again a larger scale, not in the scale of the equipment, but in the scale of the operation. So that will require additional funding down the road.
Okay, how much money we are talking approximately?
It's on the order of tens of millions of dollars. Again, depends on the scale. You can if you want to build a 100 gigawatt hour plant, it's obviously much more than that. But the idea is to proceed stepwise to really grow with the industry. Ideally, to cultivate partnerships with our customers. Potentially building the plant as a joint venture or as a captive plant. So there's lots of options, but the first step, as always, one doesn't want to get ahead of oneself. Qualify the product, build the commercial scale demonstration plant, and then the commercial operations follow very shortly thereafter if you're provided you're successful. So that's the focus.
Okay, so last part of the interview, let's talk about money also. I mean, you have been awarded 1.9 million Canadian dollars via the Blue Solutions, sorry, horrible word, project to work together with them for the Next Generation Manufacturing Canada grant. So I think that is a sign of trust, I would say, when you get the money from them for sure. And so what do you have now in the bank?
As you know, this is an exciting space, so governments are very keen to support it, and we're optimistic we're going to be able to get additional funds from those sources. In terms of our funding situation, we were able to raise about $32 million at the RTO in November, and so we're in the process of deploying that capital. It's one of the reasons we've been able to bring our production capacity online so quickly, the pilot production capacity in Rochester, and we're building out our Markham facility for the metal production demonstration plant. So we're really in the process of deploying that capital. As I said, I think we're we believe, based on our current estimates, that we're in really good shape for potentially funding the commercial scale demonstration plan for the anode. And beyond that, obviously, the significant traction we're getting from our customers, I think, will be very supportive when we go to raise the additional funds for the rest of the program.
Okay, super. So I see you have an insider ownership of 25%. Who are your next largest shareholders? Because I can imagine it's very important to have strong shareholders, because I could think of immediate M&A when everything works, because every battery metals producer would maybe own your technology.
Yeah. No. So we have as I said, we're a relatively young company. We recently went public. So the capital structure, to some extent, looks like a public company capital structure. So we have a lot of very supportive shareholders, who are keenly interested in the industry. Some, involved in other ways in the industry, and so yeah, extremely supportive group of investors. Of course, as we look to the next financing, we're looking to broaden that investor base as well, and ideally to get some institutions into the stock as well.
Super, perfect. So, Maciej, thank you very much for the interview. Very exciting, 23 minutes. Jesus Christ, a little bit long, but it's very interesting to listen to you. And yeah, keep fingers crossed. Please get it running, because it looks like the battery world needs your product, I would say.
Doubtless they need it. So thanks a lot, Johan. It's a pleasure, and appreciate the opportunity.
Super, thank you very much. Yeah, ladies and gentlemen, that was LI Metals, or LI Metals as I call it, with Maciej Jastrzebski, the CEO, and you heard it, really interesting company, quite young, only 3.5 years old, went public through an RTO some 7-8 months ago, and still have a lot of money in the bank to really go full throttle with their projects of new, I would call it, lithium anode technology, and also for lithium metal. This is really interesting, and I think this is a future project here, but not a future project within 10 years. I think within the next 2 years this is getting really important for the battery makers, and I would suggest you have a very close look onto this company. Thanks for watching us, and bye bye from Switzerland.